my name is Juan. I'm an undergraduate student at Foothill College studying molecular and cellular biology, and in today's video, I'm going to cover a seemingly simple yet tricky concept from organic chemistry known as alkane nomenclature. Let's first ask ourselves, what is an alkane? An alkane is an organic molecule made up of single-bonded carbon and hydrogen atoms. As you can see here, the purple asterisks represent the carbon atoms, and the blue H's stemming off of those carbon atoms represent hydrogen atoms. Down here, you can see the skeletal structure, simplified skeletal structure representation of this alkane up here. Naming alkanes is a simple recipe. Find the parent chain, number it, and add substituents in alphabetical order. There are 5 rules in alkane nomenclature. Number 1, find the longest continuous carbon chain. This will be your parent chain. Number 2, number the carbon chain from the end that gives the first substituent the lowest number. Number 3, name substituents like methyl, ethyl, etc., and assign their numbers in the molecule. Number 4, if substituents repeat, use di, tri, tetra, etc. to indicate how many of the substituents are there in the molecule. And number 5, alphabetize your substituents, making sure to ignore di, tri, or tetra prefixes when alphabetizing these substituents. Something important to remember is the number of carbons that correspond with each parent chain prefix. 1 carbon would correspond to the prefix meth, 2 carbons would correspond to the prefix eth, 3 carbons would correspond to the prefix prop, and then 4 would correspond with the prefix but. There are many other prefixes that correspond with the number of carbons as you increase, but we'll skip those for now. Here we have an example of an alkane. First, we can start by finding the parent chain by numbering our alkane, which is 1, 2, 3, 4, 5, and 6. You can name this alkane by going either way and counting from either side. What we have to remember is that we have to name the alkane based on which number hits a substituent first. So in this case, we're numbering it from the left side, 1, 2, 3, 4, 5, 6. And this gives us our first substituent at number 3, carbon number 3. However, if we were to name it from this side, we would name it 1, 2, 3, 4, and that methyl group right here would land on carbon 4. We're going to stick with the numbering from the left side because that'll give us our substituent on the lowest numbered carbon. That's what we want. So now that we've got our parent chain, we know our alkane is going to be named hex. That's the prefix we're going to use for it. And so now we just have to go about finding our substituents on the carbon chain. Our first substituent is going to be right here. It's going to be a methyl group or a CH3 group. And so now that we've got that right there, we're going to find which carbon that methyl group is on. That methyl group is going to be on carbon number 3. And so we can number this 3 right here and then write methyl. And then, since our parent chain is a hex, since the 6 carbons, we can go ahead and connect these and then just add an ane at the very end. So now these two together would be 3-methyl-hexane. Here's another example of alkane nomenclature. First, we're going to start off by finding our parent chain. So to do this, we're going to start numbering our parent chain and finding which will be the longest. So as we can see right here, made up a bit of a slip up, sorry. This will be number 5. So right here, we name it from this side or number it from this side, from the right side, going 1, 2, 3, 4, 5, 6, 7. The reason this is because these numbers will give our substituents on carbon 2, 4, and 5 the lowest numbers, as opposed to if we were to number it from the left side. 4, 5, 6, 7. Right, so this side would mean that our substituents would be on carbons number 3, 4, and 6, which are higher numbers than those originally 2, 4, and 5. So now that we have our carbon chain numbered, we can determine which is our longest parent chain, or which is just our parent chain. We have it numbered as such: 1, 2, 3, 4, 5, 6, 7, and we have to remember that 7 corresponds to the prefix hept. And so, now that we have that numbered, we can look to our substituents. We have one substituent on carbon number 2. This is going to be a methyl group. And then we have another substituent on carbon number 5, which will also be a methyl group. Since we have 2 substituents of the same kind, we're going to label them as such. Since this one is on number 2, we're going to label that as number 2, and then our other substituent, which is a methyl group, will be on number 5. So we'll put comma 5. And then we'll make a dash in between those. And since we have 2 of them, we're going to put dimethyl. Our other substituent, on the other hand, is going to be on carbon number 4, and it's going to be composed of 2 carbons. And so that'll make it 4-ethyl. And then ethyl corresponds to that of 2 carbons, the prefix of 2 carbons, so we have to remember that right here. And so the next step we can take in determining the alphabetical order of these substituents corresponding with the parent chain is that we can remove di from our consideration of alphabet and only pay attention to the M and the E here. So E comes before M in the alphabet, so we will write that as such. And then we can pay attention to the dimethyl. M comes after the E, so we will write that next. And then we put a dash in between to separate them. So then we will write 2,5-dimethyl. And then finally, we have to remember our prefix for the 7 carbons of the parent chain that we selected at first. And then we have to just add an ane to the end of that. That corresponds to alkanes. And finally, what we'll do is we'll just go ahead and write heptane at the very end of that. And that's how you name this molecule right here. 2 important tips and tiebreakers for alkane nomenclature. Number 1, if you have a tie for the longest carbon chain, make sure to use the one with the most substituents on it. And then number 2, you have to make sure your punctuation is correct. So commas go between numbers, and hyphens go between words and numbers. Here's a small recap of everything we've covered in this video. First, find the parent chain. This means finding the longest continuous carbon chain in the molecule. Number 2, numbering your chain in a fashion that gives your substituents the lowest numbers possible within that chain. And number 3, alphabetizing your substituents, making sure to ignore the numeric prefixes di, tri, and tetra when doing so in order to name your molecule correctly. Alkane nomenclature was a concept I struggled on at first, but with time I got better at it, and I hope this video can help you guys grasp this concept on a deeper level. Thank you for watching this video.